All right. Hello, this is WeBWorK 2.6 question 1. We were given an applet below. Unfortunately, since I am demonstrating this question on Zernal, I can't really, move the applet myself. So we'll be solving this problem analytically. We want to determine the value of M2 that will make the system balance on the fulcrum by dragging the slider for M2, but we are given values of x1 at 0.7, x2 at 4.3, and we want to move the slider for M1 so the mass is set at M1.5 and drag the center mass along the axis x equals 2. So we know for the center of mass for a system of discrete point masses, center of mass, we can just describe as x Cm is defined as sum of mass to the ith particle times x to the ith particle over the sum of all masses. So now we just see what we're given. We're given m1 is equal to 0.5. X1 is equal to 0.7 and x2 is equal to 4.3, and our center of mass, xcm, is equal to 2. Now we have xcm, and we have what we don't know. We have all of our xi's and some of our mi's. So we plug this in, we know 2 is equal to 0.5 times 0.7 plus, so our m1 0.5 times our x1 0.7 plus our m2, which we don't know. M2, I don't know what is that. And then we have our x2 4.3. And now we just need the sum of all of our masses, so 0.5 plus m2. Now the reason why we're multiplying these two is because we're finding the sum of the product of our masses and x's. So that's why these two are multiplied. Now we need to just solve for m2. And expanding this, multiplying 0.5 and m2 to one side, we can get 2 times 0.5 plus m2 is equal to, well, 0.5 times 0.7 is 0.35 plus, and just 4.3 m2. Now we FOIL this out, we get 1 plus 2 m2 is equal to 0.35, nothing else to change here, 4.3 m2. Just group like terms. You can subtract this to the other side. We get 0.65. We subtract that 2 to the other side. That gives us 2.3 m2. Now we just got to solve for m2, which is multiplied by that 2.3. And that equals, let me get out my calculator. It's got to be a long decimal. It is 0.282609 rounded. With the not rounded, it would be 87. You can round that to 9. That is our answer for question 1.